This video will focus on the concepts of fractions. So just the basic concept, what fractions are and how they are used. Will not focus on any of the operations, addition, subtraction, multiplication, or division with fractions, just what a fraction is. So first, we'll talk about the concept of partitioning a whole into equal parts. This video focuses just on halves, thirds, and fourths. And then we will discuss fractions on the number line and fraction equivalency, and then finally the different types of fraction manipulatives. So I have other videos that go specifically into how to use each of these manipulatives that you can check out. So first we have two wholes. There's a circle and a square. So they can both be partitioned into 4 equal parts. This is called partitioning, and we call each one of those parts a fourth. So it's important for students to understand this concept. Eventually, we start counting by fourths, and we start looking at parts of the whole, such as 1/4, 2/4, 3/4, 4/4, etc. When students are thinking about halves, thirds, and fourths, they need to understand that we're talking about equal sharing. So these 3 pictures do not show equal sharing, even though the first one does show 2 parts. It is not halves because they are not 2 equal parts, and so on and so forth. So this is a concept that students need to understand, and something that can help them understand this is the use of manipulatives either in the classroom or at home. This is wrong, because it's not equal sharing. So another thing that makes fractions easier to understand for students is thinking about if you were sharing something like a pizza or a candy bar or something like that, would any of these ways be fair? So the student will say no, it's not fair, it's not equal sharing because not everybody's piece is the same size. So this is what we want students to start to understand, is that equal partitioning, where we do have those fractional parts accurately represented. So all of these are fair shares because each person would be getting the same amount. Fractions on a number line can be kind of difficult for students because if the number line is not already labeled, it can be difficult for students to understand what the number line is partitioned into. So when we're looking at a number line, I tell them to count the spaces rather than counting the lines, because that is the number of pieces that there are. So if you're looking at this top number line, you see that there are 4 spaces because the number line is partitioned into 4 equal pieces. And we can use the number line to represent other visual models of fractions as shown below. The square and the circle can both be modeled on this number line. Since both of those have all 4 sections shaded in, the number line is also shaded all the way in. So that line above the number line, that teal line, would be something that a student could shade in with a pencil, or they could write with an expo marker if they're writing on a whiteboard. Fractions that are less than 1 can also be represented on a number line, as shown. So students might be asked to represent fractions on a number line. So they might be asked to look at this visual, the circle, determine what fractional part that represents, and then to shade the fractional part on a number line. And so the purpose of using a number line is when we get to fractions like this, where they're being asked to think about equivalence. So when they have a double number line or 2 number lines, one on top of the other, they can easily see the fraction equivalence. So this may or may not be accompanied by a visual model as shown on the right with those 2 fraction circles. But the purpose of using fractions on a number line is to start to examine those relationships between different fractional parts. And when we start to get into fractions that are greater than 1, so, this number line could continue into 5/4, which would be 1 whole plus 1/4. So using a number line can help to make those connections for the students. Okay, finally, these are some different fraction manipulatives. So I will have videos that describe each of these in detail. We use all of these in the classroom and they have slightly different purposes. The fractions on the left are just fraction tiles. You can purchase fraction tiles for use at home, but I also have them in the classroom for classroom use. This one is nice because it has a tray so the students can kind of line up those fractions. The purpose of students using fraction tiles is for them to start examining the relationships between the different sized parts. So if you're looking at the tenths, a student could put 2/10 and line them up with a 1/5 and see that they are equivalent. So it's a great exploratory activity for students to start to see those relationships between the fractional parts and their relative size. And that can really help students to avoid making common errors with fractions when they're adding, multiplying, etc. When they might say 1/10 plus 1/10 equals 1/20th, they're less likely to make those errors if they have hands-on experience with the manipulatives. The ones on the very right-hand side, the circles, have that similar purpose of seeing equivalents. And then the ones in the middle have a unique purpose. They do not have labels. So typically I tend to start with these because they don't have the labels that distract the students and get them to start thinking about those numbers before they're thinking about the concept of equal shares, equal parts, and the fact that you can have different fractions equivalent to each other. So we always start with the ones in the middle. I have these in a magnetic version as well as a non-magnetic version. And I have links to all of these materials if you would like to purchase them for at-home use. But there are also digital versions that students can just drag and drop. And there's also just paper versions. You could print them out on regular paper or maybe cardstock for a little bit of a more durable manipulative, and the students can use those at home for home exploration.